Welcome back to the Network Plus training series. Today we're wrapping Domain 3 with Objective 3.5, Network Access and Management Methods. This is the how do you actually touch the network objective, and I love it because it's the one place where everything you've learned so far meets a real keyboard. Here's the truth. If you can't reach a device, you can't fix a device. Doesn't matter how well designed your network is. If you're on the 9th floor and the router's in the basement and you can't SSH in, you've got an outage and a stairwell. So this objective is really about all the different ways network pros get to the boxes they need to manage. We're going to cover 3 big buckets: VPNs for remote access, the protocols you use to actually log into network gear, and the critical design decision between in-band and out-of-band management, plus a few pro techniques, jump servers, and remote desktop that every working admin needs to know. Let's start with VPNs. A VPN, virtual private network, creates a secure, encrypted tunnel over an untrusted network like the internet. And I want to stop for a second and appreciate how cool that is. You're taking packets that would otherwise be completely visible to anyone on the internet, wrapping them in encryption, and shooting them through as if you had a private fiber line between 2 points. That is the magic. There are 2 flavors of VPN you need to know cold: site-to-site and client-to-site. A site-to-site VPN connects 2 entire networks. Imagine a company with an office in New York and another in Los Angeles. They set up a site-to-site VPN between the 2 edge routers, and suddenly, as far as any user on either end is concerned, those 2 offices are on the same network. Print to a printer in LA from your desk in New York? Works. Access a file server in New York from a laptop in LA? Works. The VPN is invisible, no software on the laptops. No login prompts. It just works because the tunnel is happening between the routers, not between the devices. Site-to-site VPNs almost always use IPSec, Internet Protocol Security, for encryption. IPSec is the workhorse of enterprise VPNs. It runs at layer 3, encrypts everything, and has been battle-tested for decades. Now, client-to-site, also called remote access VPN, is different. This is what most people picture when they think VPN. You're a remote employee, you open up Cisco AnyConnect or GlobalProtect on your laptop, you type in your credentials, and now your laptop has a secure tunnel back to corporate. 1 user, 1 device, 1 tunnel. Within client-to-site, there are 2 approaches. Full client VPN requires dedicated software installed on your machine. That's your AnyConnect, OpenVPN, GlobalProtect. It handles all the encryption and authentication, gives you full network access, and is the go-to for employees on company-managed devices. Clientless VPN uses a web browser instead. You navigate to a portal, log in, and access resources right through the browser. SSL or TLS handles the encryption. It's great when you're on a machine you don't own, a contractor's laptop, a kiosk in a hotel, and you can't install software. Downside: limited functionality. Most clientless VPNs only expose web apps, not full network access. And here's the question that trips everyone up on the exam: split tunnel versus full tunnel. In full tunnel, every single packet from the user's device goes through the VPN. Checking email? Through the VPN. Watching YouTube? Through the VPN. Googling lunch spots? Yes, through the VPN. Your corporate security team sees everything. They filter it, log it, control it. Downside: every bit of that user's traffic lands on your VPN concentrator. Bandwidth goes up, user experience goes down. And that YouTube video is traveling corporate to internet and back instead of direct. In split tunnel, only traffic destined for corporate goes through the VPN. Need the file server? That goes through YouTube. That goes straight to the internet through the user's local connection. Faster for the user, less load on the VPN. But your security team loses visibility into what the user does on the open internet. That's the trade-off. Security versus performance. There's no universally right answer. Just what does your organization care about more? Okay. VPNs, handled. Now let's talk about the actual protocols you use to log into network devices. SSH, Secure Shell. Port 22, this is the standard, and honestly, it's not even close. Every switch, every router, every firewall supports SSH. You open up your terminal, type SSH admin at router IP, hit enter, authenticate, and you're in. Full command line access. Encrypted end-to-end. Supports both password authentication and The better option, public key authentication, where your SSH key proves who you are. Here's an exam landmine. SSH replaced Telnet, and the reason is brutal. Telnet sends everything in plain text. Username, password, every command you type, every output you see. Anyone running a packet capture on the network sees the whole session. If you see Telnet on an exam question as an answer option, it's almost always wrong. Telnet is dead. SSH is the answer. GUI management, graphical web-based access. Most modern network devices have a web interface. You point a browser at the device, log in, and you get dashboards, config wizards, visual monitoring. It's friendlier for initial setup and for admins who don't live in the CLI. Downside, it's slower for experienced operators. It can hide advanced options, and it's harder to automate. CLI wins for power users every time. Now, the break glass option. The console port. Every network device has a physical console port. You plug a console cable from your laptop directly into that port. Used to be a serial cable with a DB9 connector. Now it's usually USB or RJ45 to USB. And that gives you direct access to the device's command line without any network connectivity at all. This is what saves you when you've bricked a config remotely, or when the device is fresh out of the box and hasn't been configured yet, or when the network is completely down. Console access is your safety net. 9600 baud, no drama, it just works. Every working network admin has stood in a data center with a laptop balanced on their knees and a console cable in their hand. It's a rite of passage. API-based management is where modern networking is headed. REST APIs over HTTPS, JSON payloads, programmatic configuration. Instead of clicking through a GUI or typing CLI commands, you're writing scripts or using tools like Ansible, Terraform, or Python to configure devices at scale. This is the foundation of infrastructure as code. Your entire network configuration lives in a Git repository, and deploying changes is a pull request. It's the future, and it's already here. And SNMP, which we covered back in Objective 3.2, gives you another angle. Read stats, set config values, receive traps. Different use case than SSH, but absolutely still management traffic. All right, now the architectural question that really matters. In-band versus out-of-band management. In-band management means you manage devices over the same network that carries production traffic. SSH into a switch via its management IP on the production LAN, that's in-band, cheap, convenient, no extra infrastructure. But, and here's the killer, if the production network goes down, so does your management access, right when you need it most. You can't SSH into a switch that's isolated because of a loop, a routing failure, or a misconfiguration. You're locked out. Out-of-band management gives you a separate dedicated network just for management. Usually a completely isolated network with its own switches and cabling, or a console server, a dedicated box that connects to every device's console port, and you reach the console server over that separate management network, or even over a cellular modem so it stays reachable even if your entire building's internet is down. Out of band is the professional answer. Production network on fire, you can still reach every device, make changes, troubleshoot, recover, without needing to physically drive to the data center. The trade-off is cost and complexity. A separate management network is more gear, more wiring, more things to maintain. But for mission-critical infrastructure, hospitals, banks, ISPs, out-of-band is non-negotiable. Now, jump servers, also called bastion hosts or jump boxes. These are locked down, heavily monitored servers that sit between your administrators and your network devices. Instead of letting admins connect directly from their laptops to routers and firewalls, you force all management traffic through the jump server. Admin logs into the jump server first. From there, they SSH into the target device. Everything they do gets logged, audited, and controlled from one choke point. It dramatically reduces your attack surface. If an attacker compromises an admin laptop, they can't reach your switches without also compromising the jump server. It's defense in depth applied to admin access. And one more, remote desktop protocols. RDP, Remote Desktop Protocol, port 3389. This is Microsoft's protocol for graphical remote access to Windows systems. VNC, Virtual Network Computing, is platform independent and works on Windows, Mac, and Linux. Both give you the full desktop of a remote machine. You'll use these for managing servers, virtual machines, and workstations, less for network switches and more for the Windows boxes running services on them. Let's tie it all together. VPNs, now site-to-site for office-to-office, client-to-site for remote users, full client versus clientless, split tunnel versus full tunnel. SSH for secure command line device management, replace Telnet, never use Telnet. GUI for friendly web management, console port as the break glass last resort. API for modern automation. In-band is cheap but fragile. Out-of-band guarantees access during outages. Jump servers centralize and audit management access. RDP and VNC for graphical remote desktop. These are the tools that turn network theory into network operations. You can design the most beautiful network in the world, but the day comes when something breaks, and you need to reach the device that broke. Knowing which tool to reach for and when is what separates a junior admin from a senior one. That's Objective 3.5. And that wraps Domain 3, Network Operations. You've just learned how to run a network end-to-end, documentation, monitoring, high availability, disaster recovery, network services, and now access and management. That's the full operational picture. In the next video, we start Domain 4, Network Security Concepts. See you there.